concrete mix design is the process of selecting the right ingredients and their relative proportions to achieve the project requirements. So we already know in a concrete mix we have cement, aggregates, water, air if it is air entrained concrete, and also admixtures. So we need to know which cement to select. What are the properties of aggregates? For example, the particle size distribution. If we need to mix aggregates to get the required particle size distribution, we need to do that, and also we need to know the water absorption capacity of aggregates. We also need to know how much of air entrainment we need if it is air entrained concrete, and what kind of admixtures that we need to use, depending on the desired strength, durability and the workability of the concrete for a specified project. As we have discussed earlier, the objectives of concrete mix design is to select the suitable ingredients and also to determine their relative quantities. For doing this, we need to know the properties and the requirements in the fresh concrete and the hardened concrete. The properties that we are looking at in fresh concrete are the workability, compaction and the curing, and the properties that we are looking at hardened concrete is strength, durability and the shrink. In concrete engineering, compressive strength is a critical property that measures the ability of concrete to withstand axial loads or forces that push or squeeze the material. Here we are going to discuss two terms, specified compressive strength and average compressive strength, which are related to concrete strength testing and design standards. Let's start with specified compressive strength. It is the minimum strength that a concrete mix is required to achieve as per design specifications or construction codes. It is a value that engineers and designers determine based on the intended use of the concrete and the structural requirements. Specified compressive strength is usually denoted by the symbol F-C. Here in this slide you can see the minimum specified compressive strength for different exposure classifications. For example, structures in arid climate zone requires a specified compressive strength of 20 megapascal as a minimum. Structures in temperate climate zone needs a minimum specified compressive strength of 25 megapascals. Structures in tropic climate zone needs a minimum of specified compressive strength of 32 megapascals. Structures less than 1 kilometer from coast is needed a minimum of 40 megapascals of specified compressive strength. Structures with a periodic contact with water needs a minimum specified compressive strength of 50 megapascals. The average compressive strength of a concrete is the calculated average of the compressive strength value obtained from a set of concrete specimens that are tested in the laboratory. In topic 2, we discuss how to find the compressive strength of a concrete sample using a cylindrical or cubic specimen. Required average strength, which is F-CR, is the amount of strength that we are specifying the plant to produce, and it is always more than F-C, which is specified required strength. Let's see how to find this F-CR. This F-CR is depend on the variability or the standard deviation in concrete strength from the plant and also the allowable risks. Allowable risk is depend on the age of the plant, and considering the standard deviation and the age of the plant, we can find the F-CR in terms of F-C. Let's see how to find it. In this slide, you can find the equations that we can use to find the required average strength, which is F-CR. As we have discussed earlier, required average strength depend on the number of tests that the plant has done. When the number of tests are less than 15, we can use this set of equations. When the number of tests are between 15 and 30, we can use this set of equations. Also, we need the information at the bottom of the slide as well. When the number of tests are more than 30, we can use this set of equations. Now let's see in detail how we can use these equations. Let's start with the plant, which is quite new, which has done less than 15 tests. As you can see here, depending on the specified compressive strength, we have three equations to use. when the specified compressive strength is less than 21, we need to add a 7 and we can find the required average strength. When the specified compressive strength is between 21 and 35 megapascals, we are adding a little bit more, 8.5 to the specified compressive strength to find the required average strength. And when the specified compressive strength is more than 35, we need to add 10 and we can find the required average strength. So you can see here, when the specified compressive strength is higher, the number that we are adding to it is increased for the safer side. Now let's see a plant which has done tests between 15 and 30. So we are going to use these equations. So we have two set of equations here. We need to use both. So in the first one, we have to add 1.34 times S dash. S dash is not the standard deviation. It is the standard deviation times the modification factor. That modification factor you can find from the table 17.2. So depending on the number of tests, you can find the modification factor. Sometimes you may need to do interpolation to find the exact modification factor. And the second set of equations, as you see here, depending on the specified compressive strength, you need to select the right equation. For example, if your specified compressive strength is less than or equal to 35 megapascals, you can use this top equation and you can substitute the values and you can find F dash CR. After you find the value for F dash CR using both the equations here, this one and this one, you consider the larger value and that will be your required average strength. Similarly, for a plant which has done more than 30 tests, you have two equations. So from the bottom two equations, you need to select the right one depending on your specified compressive strength. For example, if your specified compressive strength is 45 megapascals, you need to use this bottom equation, which is this one. And also you need to do the same calculation using the top equation. Then you compare your results from this one and you select the larger value. So that will be your required average strength.